था वो। मैंने आयुष ट्राई किया था एक बार तुम्हारे रिकॉर्डिंग को खोलने के लिए, तो पता नहीं मुझसे क्या क्या पूछता था कि आप ये दो वो दो, ईमेल आईडी। डोंट वरी, आई विल सेंड
हाँ
यू माय रिकॉर्डिंग।
ओके सर।
So that just quickly coming to it, you can have, always remember, there is an outer speed loop, there can be inner torque loop, a current loop, and a flux loop, depending upon what type of dynamic control you require. Always remember, this flux loop is very important because an optimum value of flux makes your drive to have energy efficient operation. It helps us to have an energy efficient operation because torque is a cross product of flux and armature current. So to get the required amount of torque, if you have control over flux, then you can directly control the torque by maintaining the current. इसको ऐसे बोल सकता हूँ कि टॉर्क दो कंपोनेंट्स का प्रोडक्ट है, फ्लक्स और आर्मेचर करंट का। तो अगर आप फ्लक्स को इंडिपेंडेंटली कंट्रोल कर सकते हो और उसको एक रिक्वायर्ड वैल्यू पर सेट कर देते हो, जितना आपने सोचा है, सोचने से मतलब है किसी भी ड्राइव में जो फ्लक्स की सेटिंग होती है कि हमें मशीन को कितने फ्लक्स पर चलाना है, वो कई चीजों पर डिपेंड करता है। एक होता है उस वक्त लोड टॉर्क कितना लगा है उस मशीन पे, दूसरा आप किस स्पीड पर ऑपरेट कर रहे हैं। ये दो पैरामीटर्स ऐसे होते हैं जो डिसाइड करते हैं कि मशीन को कितने फ्लक्स पर चलना है। अब मशीन को कितने फ्लक्स पर चलना है, इसके लिए जरूरी है कि हमारे पास कुछ इस तरह का एक लूप हो जिसमें कि कंट्रोल सिस्टम कॉन्फ़िगर हमें कितना फ्लक्स चाहिए था, दिस इज रेफरेंस फ्लक्स, और एक्चुअली कितना फ्लक्स ऑपरेट हो रहा है, और इस एरर को ऐसे प्रोसेस करेंगे जिससे कि ये एरर मिनिमाइज हो जाए। वी कैन मिनिमाइज दिस एरर। सो दिस इज नोन एज दिस फ्लक्स लूप। नाउ टॉर्क लूप और करंट लूप आर synonymous, or they are same as speed loop. So as we have seen in the DC machine, and just making you a recap of what we have seen in DC machine quickly. There was reference speed was compared with actual speed, and the error was processed with the PI controller. I have explained what is PI controller. It generates a reference torque command. Reference torque command was again given to a PI controller, which gives a reference current, I star. Now you can compare reference current with actual armature current. Remember, you can compare the reference armature current with actual armature current. So now your speed control totally depends upon your current control loop. But this is only possible when you have a separate loop which should have this type of shape. You should set some reference flux. It should be compared with actual flux, and then the error should be processed such that you can maintain this flux. But we know that this was possible in DC machine, because in a DC machine you have two separate sets of winding. One is known as armature winding, another is known as field winding. But in an AC machine, you don't have such separate sets of winding. So in AC machine, you will be incorporating some different techniques. And that different techniques is nothing but you will be using some algorithms, some advanced algorithms. These algorithms were developed in late 80s, right? So history says that about 100 years or 150 years before, both DC as well as AC machines were invented simultaneously. But DC machines have ruled the industry, whether it was engineering, whether it was industry, whether it was railway, whether it was traction, or any other application. Mostly DC machines were used. The only reason being they had two separate machines which would give this type of decoupled current. But then in late 80s, people developed some latest algorithms. Those latest algorithms that were developed by researchers, industry, were based on a very important concept, and that is to inculcate the performance of a DC machine in an AC machine. And you will be surprised to know that this statement which I am giving, I hope my sound is clear and I have not lost connectivity. I hope.
Yes, sir.
Okay. Please let me know if I lost my connectivity. Otherwise, I'll be simply firing the bullets in air. That's all. है ना? हवा में बोलता रहूँगा, पता नहीं चलेगा आप तक पहुँचा। Fine. So this statement which I am showing you is to inculcate the performance of a DC machine in an AC machine. This I have read about 10 years before. At that time, there were no electric cars, there were no electric vehicles, but still people were shifting from DC to AC. Then there was a very revolutionary change occurred, and when electric vehicles emerged, and now this statement has become very relevant to today's scenario. तो इसीलिए traction हो, whether it is electric traction train or electric vehicles, so now industry is shifting from DC to AC. So what research or what complex algorithms were developed by the researchers for AC machine? I'll just explain you this with a simple block diagram. So not be not मतलब उसका derivation नहीं करना. We'll do something like this. Your currents I, A, IB, and IC, or you can say VA, VB, and VC. This is known as natural frame of reference. This is known as natural frame. ABC frame. इसको बोलते हैं ABC यानी कि isn't it? Now what we'll do is, but people thought, if we could have some transformation of this ABC reference frame to two-axis reference frame. Two-axis reference frame. So how can you say that ABC reference frame? Let us say this is A axis, this is B axis, and this is C axis. Equivalently, we can form an axis system which would have two axes, alpha and beta. And what you will do is, let us say I am taking an example of a current vector. Always remember, in electrical engineering, we will be talking about current vector, hydromotive force, or flux. These three components, these three parameters are the parameters which are used for dynamic control of dynamic control की use. तो imagine करो कि एक 3-phase की इंडक्शन मशीन है. उस 3-phase की इंडक्शन मशीन में जो तीन करंट्स होते हैं IA, IB और IC, उनसे एक इक्विवेलेंट एयर गैप मैग्नेटोमोटिव फोर्स पैदा होती है जिसको हम बोलते हैं रिजल्टेंट एयर गैप मैग्नेटोमोटिव फोर्स FR. So it is assumed that this FR is produced by some resultant current IR. So this concept is known as the concept of space vector. Space vector का मतलब ये है कि you have transformed IA, IB and IC into a single space current vector I. मतलब तीन करंट का इक्विवेलेंट एक सिंगल करंट से. और इसको करने का सीक्वेंस ये था कि सपोज करो आप, मैं इलेक्ट्रिकल इंजीनियरिंग की बात नहीं करता हूँ, फिजिक्स की बात करता हूँ. आपके पास तीन वेक्टर है x, y और z. तीनों 120 डिग्री पर है. आपसे पूछता हूँ कि फाइंड द कंपोनेंट ऑफ ऑल दीस वेक्टर्स अलोंग x एक्सिस and find the component of all these vectors along y axis. So I hope I have not talked about rocket science, isn't it? It is very easy to find the component of three vectors which are along three axes and transform it to two axes. So that one will be along D, one will be horizontal axis and one will be vertical axis. For example, इसी केस में देखते हैं, और I can say that this one जो मैंने अभी आपको ये वाला let us say A phase is aligned along this alpha imaginary axis. So you can say that ये जो भी वेक्टर था वो यहाँ था. अब मैं चाहता हूँ कि इस B वेक्टर का कंपोनेंट इसमें पता करूँ x axis. What will be? It will be equal to B cos of 120, isn't it? So B cos of 120 will give me the component of IB along this x axis. And C cos of 240 will give me the component of IC along x axis. I hope it's clear to you.
Yes, sir.
Yes. So quickly, we can say that in this way we can transform any quantity which are in natural reference frame of ABC reference frame to alpha beta reference frame. This was the first transformation developed by engineers. Then they thought that those engineers, they did more research and they thought that why don't we make a, this was our reference system, this was BP, this was page. Let us say this is A phase, this is B phase, this is C phase, A, H, C, and this is the natural frame of reference, ABC, right? What we do is, let us assume that we are having an XY system or an two-axis system. Now we'll give the name as DQ system. And this DQ system is not stationary in space. In fact, it is rotating in space. ये घूम रहा है, right? So when it is rotating in space, then what will happen is, it was found that if you could find the component of this ABC components which were in natural reference frame along a rotating reference frame, and this rotating reference frame जो हमने मानी है उसको ऐसा मान लिया कि लेट अस से it is aligned along the rotor axis, मतलब जो आपका इंडक्शन मशीन का जो रोटर है उसका जो एक्सिस होता है वो डी एक्सिस के साथ अलाइंड है। तो मैथमेटिक्स से ये प्रूफ किया गया था कि IA, IB and IC can be transformed into two components, ID and IQ. ID will be along the x-axis of this rotating frame and IQ will be along the y-axis of the rotating frame. Then they found that this ID will behave same as field current and IQ will behave same as current. Is it clear? I hope it's clear.
Yes, sir.
Yes. You don't have to go into the details of the derivation because they are very big derivation. But I just want to show you the conclusion that the three-phase quantities in natural reference frame can be transformed into two-axis system which is rotating in space, so that you can transform the currents to, you can get two components of current, ID and IQ. And later on it was seen through mathematics that ID will be same as field current and IQ will same as armature. That means ID in an induction machine can current its flux and IQ can control the torque. So this was a very breakthrough, you can say, algorithm was developed, and this developed algorithm was then used by a company known as KBV in 1980, and he gave it the name as field-oriented control. It was known as field-oriented control or vector control. It was known as vector control. Now, if this was vector control, obviously there would have a scalar control. So scalar control is nothing but your V by F. So ये आपने मशीन में पढ़ा है। इंडक्शन मशीन में जब आप V by F कंट्रोल करते हैं, you are actually controlling the magnitude of the flux. You don't have any idea of where flux is aligned, where it is going. So this is not a scalar control. But this technique which I have told you, this one, yes, where ABC transformation is transformed to DQ transformation. This transformation basically deals with not only the magnitude of the flux, but it also deals with the orientation of the flux. Therefore, this theory is the theory for this vector control. And coming to the final conclusion, this vector control is say vector control or field oriented control is the technique now which is used by railways for their engines. Now they are designing three-phase induction machines, and they are controlled by this field-oriented. Also, these machines are also used in some electric cars, and also they are using the same technique. So right now, I have explained you an advanced, in brief, an advanced control algorithm for the control of induction machines, which may be applicable to electric traction or for electric vehicles. So हमने एक क्वेश्चन को कवर किया है जो मैं पूछ सकता हूँ। अगर मैं हाइब्रिड इलेक्ट्रिक व्हीकल पूछूंगा तो my question could be asked in this way: why there is a shift from DC machine to AC machine, and briefly explain any dynamic control scheme of a three-phase induction machine. Is it clear to you? I hope it is clear to you.
Yes, sir.
Now let us start our traction chapter. Now, इसके सिलेबस में इलेक्ट्रिक ट्रैक्शन में मेनली तीन मेजर सब पार्ट्स हैं. फर्स्ट इज type of traction. Second is mechanism of train movement. And third is control of those drives for traction. It is a big unit. So since I am the teacher of this subject, I have seen what type of questions are asked in this subject. So we will be focusing on the points, that topics which are important. So quick coming to type of traction. This here, it will be more of a theoretical type of things. I'll share you the chapter where the different types of electric tractions are there. In J.V. Gupta book, you will see that in electric traction, you will see steam traction, diesel traction, diesel electric traction, all electric traction. I hope I don't have to explain this to you. Everybody of us are aware of a traction. Say, अगर मैं बोलता हूँ diesel traction. I hope you know what is diesel traction. है ना? Any railway engine which is driven by a diesel engine. Even still, I am seeing in this J.V. Gupta book since this was done way back across the long time before. So there are still some topics on steam traction. Anybody of you have physically seen a steam engine? Running steam engine? Anybody? Hello?
No, sir.
Ayush, other than Ayush, I want an answer from you. Like who is
No, sir.
Who is Lokesh? Lokesh,
Yes, sir. Yes, sir.
have you seen any steam engine? No. Yes, very true. You may have seen the steam engines in old English movies like Harry Potter. Like Harry Potter.
Sir, I am not able to hear your voice properly, sir.
Ayush, are you able to hear my voice?
Yes, sir.
I hope Lokesh, it is problem from your network.
सर वो आपकी आवाज बीच बीच में ब्रेक हो जाती है मतलब थोड़ा
तो
सुनाई
आप-
देता है फिर बाद नहीं
आप
देता
लोगों से मैं आप लोगों से यही कहना चाह रहा था। आप लोगों ने वहाँ से बोला जब भी मैं संवाद करता हूँ, when I interact, I only interact with a single person, that is Ayush. He replies, I ask him, so if he says everything is good, I feel everything is good. So that's why I want an interactive session. At least you must let me who is able to hear this. I hope Ayush, you may be hearing the sound clearly, or there was a break in sound.
सर सर जब आपने क्वेश्चन पूछा था फर्स्ट टाइम तब ब्रेक नहीं हुआ था, बट सेकंड टाइम में स्टीम इंजन के टाइम पे ब्रेक हो गया था, तो उसको
हाँ,
सुन नहीं पाए
ठीक है।
होंगे। बाकी तो सेंटेंस सबको क्लियर
कोई-
सुनाई दिया होगा।
कोई बात नहीं। तो मेरा क्वेश्चन यही है कि क्योंकि हमारे सिलेबस में अभी भी हमको स्टीम इंजन पढ़ाए जाते हैं, इलेक्ट्रिक, बट फॉर छोटा सा इंट्रोडक्शन है कि व्हाट इज स्टीम ट्रैक्शन, व्हाट आर दैट, एंड एवरीबॉडी ऑफ अस नो, आई डोंट हैव टू एक्सप्लेन यू दैट कोई जमाना था जब स्टीम इंजन चलते थे, लेकिन फिर बाद में स्टीम लोकोमोटिव सब बिल्कुल आउट हो चुके हैं फ्यूल। और आई फील स्टिल शायद ये जो हेरिटेज रेलवेज है, जैसे कि टॉय ट्रेन है, दार्जिलिंग रेल्स है, ये जो पहाड़ों पे जो चलती हैं, जहाँ पर अभी भी इलेक्ट्रिसिटी शायद ना पहुंच पाई, देयर मे बी दिस नैरो गेज स्टीम इंजन्स मे बी। बट एज अ स्टूडेंट मैं तो स्टीम इंजन में बैठा हूँ। आई हैव सीन स्टीम, traveled in steam. So no need to explain. Everybody knows the disadvantage of steam traction. A lot of pollution, very low efficiency. You can't achieve fast speed. So then there were internal combustion engines, IC engines. So in internal combustion engines, there were diesel traction and petrol traction. Although I have never seen petrol traction anywhere, but maybe for some applications, maybe some inside some mines or some places where you could not afford this diesel or you require some quick torque. So there maybe there is that petrol traction. But if we go historically, if we go by the evolution of electric drives, then we know that screen is visible to you. If we go to the evolution of electric drive, first there was steam traction, then there was diesel traction, then there was diesel electric traction. Anybody can give what do you mean by diesel electric traction? Diesel electric traction means your rail engine will have a diesel generator inside. You will have a diesel engine inside your engine. That diesel engine will burn diesel, and that will produce electricity, and that electricity will be used to run the motor, electric motor, which is driving your railway. I hope you got my point. समझ में आया ना? मतलब रेल चलेगी इलेक्ट्रिक मोटर से, लेकिन उस इलेक्ट्रिक मोटर को जो सप्लाई मिलेगी वो ओवरहेड से नहीं मिलेगी, रेल का इंजन खुद अपनी सप्लाई जनरेट करेगा। अब रेल का इंजन सप्लाई कैसे जनरेट कर सकता है? ऑब्वियसली रेल के इंजन के अंदर कोई बड़ा डीजल जनरेटर यूज किया जाता है और वो बड़ा डीजल जनरेटर may have generated electrical energy, and that electrical energy was utilized by the motor to run the train. This is known as diesel electric traction. Obviously, diesel electric traction will have less efficiency compared to diesel traction, because in diesel traction, you are directly converting the heat energy of your fuel to mechanical energy. But in diesel electric traction, you are converting the heat energy of your diesel to electrical energy and electrical energy to mechanical energy. So these two stages of conversion of energy may have resulted to lower efficiency. If you wish to note down, yes, tell you, it is the data that is given to us that it's a very good data. Steam locomotives have 6 to 8% of efficiency. Steam locomotives. Your steam locomotives have 6 to 8% of efficiency. Your diesel electric locomotive have 25 to 30% of efficiency. And electric locomotive which is fed from thermal plant. Remember, electric locomotive which is getting its electrical energy from thermal plant. It is having an efficiency of 35%. And electric locomotive which is getting its power from hydro plant is having an efficiency of 40%. So from this data, it is quite, you can see that the best option is reduce the electricity by non-fossil fuel type of system and use that electricity for traction purpose. You will have maximum efficiency. Because I have seen somewhere, एक मैंने इंडिया में कहीं ऐड देखा था कि आप हिंदुस्तान में कोयला जला के बिजली पैदा कर रहे हैं और कोयले से जली हुई बिजली से इलेक्ट्रिक कार चला रहे हैं. So it is just useless. I hope you got my point. है ना? It is
Yes,
serving
sir.
no purpose. It is serving no purpose because आपने environment पे तो वही impact डाला है, उतना ही thermal power plant से कोयला जला के बिजली पैदा करी. So until and unless we are not going to be dependent on these fossil fuels, and we are not going to shift to renewable energy sources, until then your electric traction, especially for electric vehicles, will not be feasible. But railways you have to finally, हम जानते हैं कि रेलवे के सबस्टेशंस पे जो बिजली आती है वो तो ग्रिड से आती है, और हिंदुस्तान की ग्रिड का मेजर पोर्शन अभी भी डिपेंड्स ऑन coal based electricity. But thanks to our government since last 10 or 5 years, we are investing lots of money in solar, wind, in nuclear. So maybe a time may come that a major portion of the electricity may be generated from this renewable energy sources. Then we can say that we have achieved our task. But we all know that the advantage of electric traction was not only its fast response and low impact on the environment, क्योंकि सीधे हम ये देख सकते हैं कि सीधे अगर आप कोयला जला के स्टीम बना के उसको चलाते हैं तो 6 से 8% की एफिशिएंसी मिलती है, लेकिन उसी कोयले को जला के बिजली पैदा करके और उससे बिजली को इलेक्ट्रिक मोटर को देते तो 35% efficiency. So efficiency always stays. Second important advantage of electric traction, as we all know, is electric braking, which we have studied in electric drives. I hope you remember electric braking. And in electric braking, especially regenerative braking. Regenerative braking. So I hope you remember what is regenerative braking.
So the motor will start acting as generator.
And I don't know whether I have shared this data with you, class, but once we had a lecture of an IES, Indian Engineering Service officer who was in the R&D department of railway. He told in some lecture that railway recovers 30% of its energy in the form of regenerative braking. So if we can go by his data and if we can believe that he's right, it's a very good figure. 30% recovery is a very good figure, isn't it? And as an electrical engineer or as an engineer, we can believe that rail is a very heavy rolling mass which gains a lot of kinetic energy when it's running, and continuously on the electric trains, on the electric tracks, there are thousands and thousands of trains are running. So you can believe how much amount of cumulative kinetic energy is stored in this rolling mass. So these rolling masses, all of them, sometimes some may be going straight track, some may be going up the gradient, some may be going down the gradient. सब एक जैसे तो नहीं चलती, तो कोई बिजली ले रही होगी तो उस वक्त कोई बिजली दे रही होगी. So if you believe the data, then it's a very good figure that railway recovers 30% of kinetic energy regenerative. So which is one of the biggest advantage of electric traction. Now, the thing which I have discussed you, we all know that other than this electric traction, there are some new form of traction we are seeing. Have you heard of this name MEMU? You have heard of this trams? Obviously, you may have heard this metro. Have you heard this? I hope you may have seen or
Yes.
traveled also. ना
Yes,
ये
sir.
मेमू जो है, मेमू इसका फुल फॉर्म है मॉडिफाइड इलेक्ट्रोमोटिव यूनिट. Modified electromotive unit. I have seen this train. Normally it runs उज्जैन के आसपास नहीं चलती है. इसके अलावा I have seen this मेमूज running between Delhi and Ghaziabad and Faridabad. So suburban distances. Suburban means like you want to go from if we are in a big town or a city which has suburban areas where people are living some other place and they are going to work, they are going for their workplace to some other place like Mumbai and Thane, and Delhi and Faridabad, Delhi and Noida. So there they used to have these trains, this menu. Then trams, as far as I know, I have seen many old movies. Trams were only running in Calcutta. Other than Calcutta, can anybody update me? Calcutta के अलावा कहीं और trams चलती है? नहीं चलती. है ना? ट्रैम्स आपने देखी? ट्रैम्स का फोटो कभी सी? इलेक्ट्रिक ट्रैम
ऑनलाइन ही देखी सर, ट्रैम की तो
ऑनलाइन
सर।
है। रोड पे चलती हुई गाड़ी होती है ट्रेन, ऊपर उसके ओवरहेड वायर होता है, बीच बीच में चलती है, बहुत धीमे चलती है, बड़े नॉस्टैल्जिक सी फीलिंग देती है। दैट इज इलेक्ट्रिक ट्रैम्स, स्पेशली when you see some old Hindi movies, then you will see that trams. Now, right now, other than Calcutta, we don't have trams. And metros, wonderful. There are wonderful revolutions in metros. Who is the metro man of India?
So his name is something like Sridharan or something like that.
Yes, very good. R. Sridharan is the metro man of India. And I hope most of you may have traveled in a metro in Delhi. If you have not, at least try once. It's really an experience where you feel that you are in a foreign country. And you may have also traveled in a local train in Mumbai. How many of you have traveled in a local train in Mumbai?
So I have traveled.
So,
You have. So
sir,
you very well know, है ना? You very well know the experience. आपको
Yes.
अंदर घुसने की जरूरत पड़ती है, भीड़ आपको अंदर कर देती है. And
Yes.
भीड़ ही आप धक्के से बाहर करती है. I have even seen some videos of Japan local train where they are
Yes.
where they are policemen, they used to shut the door और लोगों को धक्का देके अंदर करते और ट्रेन का वो बंद करते हैं. So these are also
Yes.
different. These are all different from traction systems. So in the next class, we will see the classification of electric traction. From our syllabus point of view, electric tractions will be divided into three categories. One is mainline service, second is urban, third is semi-urban. We will see in detail. Mainline service is when the distance between the stop is greater than 50 kilometers or more. So like a train going from Delhi to Srinagar, Bhopal to Delhi and so on. These comes under the category of mainline service. Urban service, you know that शहर के अंदर ही चलने वाली सर्विसेज को हम बोलते हैं urban service. Semi urban means urban से थोड़ा बड़ा, mainline से थोड़ा छोटा. An example is train going between Delhi and Faridabad, Mumbai to Thane, Noida to Delhi. So such type of services, such type of train service comes under semi urban. And now, needless to say that whether it is main service or it is an urban service or it is semi urban service, we all are running our electric engines with electricity. We are running our engines with electricity, so they are electric traction. But some cases it will be AC traction, and in some cases it may be DC traction. And I will just see from internet whether the metro runs on AC or DC traction. Even if anybody has any update, then he can give me the update. It's quite sure that Mumbai ki local train runs on DC traction. Do you know that? In Mumbai, the trains run in DC traction. इसीलिए पुराने जमाने में, आजकल तो नहीं, पुराने जमाने में जो ट्रेन आती थी यहाँ से बाहर से मुंबई में एंटर करती थी, इगतपुरी पे दे हैड टू डू सम चेंजेस बिकॉज वहां से डीसी ट्रैक्शन भी शुरू हो गया, कुछ ट्रैक्स पे डीसी लाइन. So with this, we have seen an introduction to electric traction, the history of electric traction, the different types of traction system. Now we will study detail the next topic, which is classification of these different electric traction systems based on their speed and time curve. And I am ending with my class with a note that
Sir,
yes, please.
sir, I have a doubt. Sir, can regenerative braking can be done in induction motors?
Yes, it can be.
Sir, but
It can be.
it can't produce. It can't produce. Sir, it can't produce a reactive power by its own. So it needs
that
to.
that is the thing. That is one of the biggest issues with it. But
So it.
there are some other.
Yes,
There
sir.
are some techniques by which you can implement this thing, regenerative braking induction machine. There are some techniques. I will
Yes.
explain you. I will explain you later on how you can implement this regenerative braking in induction machine. Basically, induction machines, if you see that nowadays induction machines are not running on pure AC. They take AC, right? They take an AC supply. Then they convert that AC to DC. Then that DC is again converted to AC with the help of an inverter. So now power electronics will play some role. You will be incorporating some braking chopper between that DC and AC, which will help us to recover back the energy. That means मैं आपको कभी डिटेल में समझा दूंगा कि वो किस तरह से अचीव किया जा सकता है, बट ऑब्वियसली योर क्वेश्चन इज क्वाइट justifiable that they do not have a reactive power source, so that's why they are the biggest challenge in regenerative braking induction system. We will discuss it in some other classes. Okay.
Yes.
I will share a MATLAB model with you in which you will see how regenerative braking is achieved in an advanced electric car. जो मैंने आपको एक कॉन्सेप्ट बताया ना ब्रेकिंग चॉपर का, ये ब्रेकिंग चॉपर नाम का एक डिवाइस पहले एसी को डीसी में कन्वर्ट करते हैं अनकंट्रोल्ड रेक्टिफायर से डायोड रेक्टिफायर से। डायोड रेक्टिफायर की जो डीसी सप्लाई है उसको एक ब्रेकिंग चॉपर को दिया जाता है। ब्रेकिंग चॉपर की डीसी सप्लाई दी जाती है एक इन्वर्टर को, इन्वर्टर से मोटर चलती है। जो बीच में जो ब्रेकिंग चॉपर होता है इसकी फायरिंग और उसको इस तरह से कंट्रोल किया जा सकता है कि यू कैन पंप बैक द सोर्स द पावर फ्रॉम motor side to your this thing source side to that DC. It is one of the techniques by which you can implement regenerative braking. Okay. So I am ending my class. और मैं जो बीच में छूट गया था, you will be surprised and you will feel very happy that this chapter of yours is more of physics. मतलब जब हम इसके सवाल सॉल्व करेंगे so you will see the problems based on Newton's law of motion, the equations of speed, distance, time, acceleration, moment of inertia. So the questions will be more of physics, and there will be some new concepts will be introduced. So you will see that there will be less of electrical engineering in this particular unit. And more of mechanical engineering. और मैं ये समझता भी हूँ कि रेलवे इज ए डोमेन जो 50% इलेक्ट्रिकल का 50% मैकेनिकल। इलेक्ट्रिकल से हम बिजली पैदा कर रहे हैं, पावर पैदा कर रहे हैं, बट उस पावर को मैकेनिकली यूटिलाइज करते हैं। सो यू हैव टू अंडरस्टैंड how much electric power is required to overcome the friction. You have to understand how much electric power will be required to go up the gradient. Actually, you will be surprised. I would like to add one thing. चलो अच्छा है. I hope you are listening. हमें कुछ क्लब्स बनाने हैं. इससे थोड़ा हट के बात. क्लब्स समझते हो क्लब?
Yes sir.
सोसाइटी. तो हमें कुछ टास्क दिए. तो मैं नेचुरल साइकिलिस्ट हूँ, मतलब मैं डेली 40-50 किलोमीटर साइकिलिंग करता हूँ। 30-40 किलोमीटर हो जाता है, छुट्टी के दिन लंबा चला जाता हूँ। I feel I will someday go for a cross country cycling. I am practicing for myself. तो मैं साइकिलिंग क्लब बनाना चाहता हूँ, बाइसाइकिलिंग क्लब। तो आपकी क्लास में से जितने भी लोग who are bicycle enthusiasts or who wish to go for bicycling, they can join my study group. है कुछ ऐसे क्लास में?
सर अब तो पता नहीं सर, क्योंकि इतने टाइम से कोई बाहर निकला नहीं है ना।
नहीं,
रहा भी होगा तो सब छूट गई होगी उसकी।
छूट गई
क्योंकि हम लोग भी ऐसे साइकिलिंग करते थे, बट वो